Hey everyone, welcome to homework 5.2. So today we looked at quadratic equations and how to solve them when we have something that equals a perfect square. So let's go ahead and take a look at number 1. It says just consider the equation x squared equals 9. Show that 3, -3, square root of 9, and negative square root of 9 are each solution to the equation. So if I were to plug in 3, I get 3 squared. That equals 3 times 3, which equals 9. If I plug in -3 squared, now I'm plugging in -3 for all of x, so I'm putting that parentheses around it. So then that equals the same as -3 times -3, which also equals +9. And then if I have the square root of 9, well, the square root of 9 can equal either positive or -3. And so that would be the same as the first two examples. And when we square a square root, we just get what's inside the square root. So similarly, -9, because this is doing a negative square root of 9 times a negative square root of 9, we would get a +9. All right, so that's a key point there, that the square root of a number times the square root of a number, or the square root of a number squared, just equals what is inside the square root. It says show that 9 and the square root of 3 are not a solution to the equation. So if I plug in 9 squared, that equals 9 times 9, which equals 81, and 81 does not equal 9. Similarly, if I put in the square root of 3 squared, that is the same as the square root of 3 times the square root of 3, which is the same as 3, which does not equal 9. So this says solve x minus 1 all squared equals 16. So here's where we would take the square root of both sides. When we do that, we get x minus 1. Taking the square root of a square leaves what's underneath the square, right? So if I take the square root of 4, for example, it gives me 2, because 2 times 2 is 4, right? So taking the square root of this is taking the square root of x minus 1 times x minus 1, right? So when I take the square root, only one of these is left in one of the parentheses is left. So this equals x minus 1, and then the square root of 16 is positive or negative 4. So now I'm going to set up x minus 1 equals positive 4, and x minus 1 equals negative 4. I'm going to add 1 to both sides, and I will get x, this cancels out, equals 5, or, oh, excuse me, I wrote this wrong. Come on, Racer. There we go. This should be -4 or -5. I got ahead of myself. All right, so here then I'm adding 1 to both sides again, and I get x, this cancels out, -3. All right, here's one way to solve the equation. Explain what is done in each step. So, oops, I went too far down. Okay. All right. There we go. All right. So in this first step, we notice that we have gotten rid of There we go. Okay. I've gotten rid of the coefficient of 5/9, and then also moving from this step to this step, I multiplied by 9. So the first step is to multiply both sides by 9. That's super important, right? So when I multiply both sides by 9, I get just y squared, sorry, just 5y squared, because 9 divided by 9 is 1, and then times 9 times 5 is 45. All right, well then the next step to solving this is I want to get rid of this coefficient of 5 completely. So to do that, I divide both sides by 5. So divide both sides by 5. When we do that, we're left with y squared equals 9. And so then it says the answer is either 3 or -3, and to get that, we take the square root of both sides. So square root of both sides. And remember that when we take the square root of a number, it can either be positive or negative, because a negative times a negative is a positive. Diego and Jada are working together to solve this quadratic. Diego solves the equation by dividing each side by 2 and then adding 2 to each side. He writes x minus 2 equals 50 and then x equals 52. Jada asks Diego why he divides each side by 2, and he says, I want to find a number that equals 100 when multiplied by itself. That number is half of 100. What mistake is Diego making? So make sure you are listening here, because I'm just going to say it. I'm not going to write it. The mistake that Diego is making here is that when we add 50 to itself, right, 50 plus 50 equals 100. But when we multiply, 50 times 50 does not equal 100. So he's mixing up adding the same number with multiplying this number by itself. And so if I were Jada, what I would say to Diego to help him realize his mistake is, what does he get in this answer? Well, he gets a 52 in this answer. So one thing that you could have him do is plug that into the original equation and see if that works. So you could say plug in x equals 52. You could also ask him, what is a number that multiplied by itself gives you 100, right? So asking him some questions to help him make his realize his mistake. You could also just tell him 10 times 10 equals 100, and that's 10 times itself, right? And so recognizing he's mixing up the idea of a square, which is multiplication, with repeated addition. All right, number 5. As part of a publicity stunt, an event designed to draw attention, that's what a publicity stunt is, a TV host drops a watermelon from the top of a tall building. The height of the watermelon t seconds after it is dropped is given by this function here, where h is feet. So this is how high the watermelon is off the ground after it is dropped. We see that because we have minus 16t squared, so that's the gravity pulling it down. It says find h of 4. So if I'm going to find h of 4, I'm going to do 850, there we go, minus 16 times 4 squared. Now remember, in our order of operations, we need to do the exponents first. So if you've forgotten a couple of you said, what order of operations? So PEMDAS, parentheses, exponents, multiplication or division, and then addition or subtraction. So we need to do this exponent first. So we're going to make 850 minus 16 times 4 squared is 16. All right. And then you can go ahead and calculate that. You can use your calculator, that's fine, but then calculate that. Remember, you need to do this multiplication first and then subtract from 850. This value, it says, what does this value mean in the situation? So make sure you say this value means after 4 seconds what the height is, right? Because this is the input here. And so that means at 4 seconds, the watermelon height is whatever you get here, okay? So do that calculation. You can do that part yourself. Then it says find h of 0. So I'm going to plug in 850 minus 16 times 0 squared. And 16 times 0 squared, so 0 squared is 0. 0 times 16 is 0. So this is just going to be 850. And you might have been able to tell that from this equation because that is the starting amount. So that's the starting height at 0 seconds. All right, the next part to this asks us, will the watermelon still be in the air 8 seconds after it's dropped? So there's a couple ways we can figure this out, right? We can just go ahead and plug in 8 seconds, so 8 squared, and see what we get, right? And we can calculate that. You can use your calculator if you like. So 850 minus 16, rid of that, 16, times 8 squared is 64. Right? And we get negative 164 here, which means that that would be below the ground, right? So again, it was negative 174. Let's flip back to this. So negative 174. So no, it already hit the ground. We could also plug that into the calculator and graph it and see what does it look like at 8 seconds, right? Where is the y value at x equals 8. All right, number 6, a zoo offers unlimited drink refills to each person who purchases a souvenir cup. The cup and then the first fill costs $10, and then refills after that are $2 each. The expression 10 plus 2r represents the total cost of the cup and r refills. So this, notice, is a linear equation. So this number 6 is a review. This is something going back to your linear equation understanding. So a family visited this zoo several times over a summer. That summer they paid $30 for one cup and multiple refills. How many refills did they buy? So our expression is 10 plus 2r. We're trying to find the number of refills, which is represented by r, and we know they spent a total of 30. So now I can solve for r by using my inverse operation. So I have 10 plus 2r equals 30. I'm going to subtract 10 from both sides. And the reason I'm doing this inverse operations, right, PEMDAS, means that I'm working backwards. Usually I start with parentheses, exponents, multiplication, division, addition, subtraction. I'm starting with addition and subtraction. I'm working inverse, backwards. So I'm starting by subtracting 10 because that's not being multiplied, it's being added there. And so I'm left with 2r equals 20. Now I'm moving into the multiplication and division section. So I'm going to divide both sides by 2, and I get r equals 10. That means that they bought one cup, they had 10 refills, and then they therefore have spent $30. Now, a visitor has $18 to spend on drinks at the zoo today and buys a souvenir cup. How many refills can they afford during the visit? So again, we have the same expression, 10 plus 2r equals 18. Now, it says they have 18, so it might be that we can't divide this or break this up evenly. And if they have 18, then I have to spend less than or equal to 18. So I'm going to write this as an inequality because we don't know exactly what's going to happen here. So I'm still doing the same inverse operation. So I'm subtracting first because we're working backwards here. And I get 2r equals 18 minus 10 is 8. Divide both sides by 2, and so r equals 4. That means I'm able to have, I should say less than or equal to. I can have less than or equal to 4 refills. So I can have 1, 2, 3, or 4 refills with that amount of money. Says another visitor spent $10 on this deal. Did they buy any refills? Explain how you know. Remember, the equation is 10 plus 2r. So if they already spent $10, can they get any refills? No, because the cup and first fill are $10, right? That alone is $10, and so we can't get any refills if we've spent $10. All right, if the equation x plus 10 times x equals true, which statement is also true according to the zero product property? Remember, this means that if one part of this equation, one part of the product is, or of the multiple is 0, then the whole thing is 0, right? If one factor equals 0, the whole thing equals 0. So x plus 10 equals 0, or x equals 0. And that leaves us with b. This would mean that x equals negative 10 and x equals 0 are solutions. If I plug in negative 10 here, negative 10 plus 10 is 0. 0 times anything is 0, right? If I plug in 0 for this x, anything times 0 is 0, so those are the two possible solutions. What are the solutions to this equation here? So in this sense, in this case, the equations I'm going to set up are 10 minus x equals 0 and 3x minus 9 equals 0. In order to solve this, you can do this a couple ways. Remember, we're doing inverse operations, so we're starting with addition and subtraction. In this one, there is no multiplication unless you count that negative in front of the x. But what I'm going to do is I'm going to add x to both sides because now I will get 10 equals x, or x equals 10. And you could reason this out because 10 minus 10 equals 0. All right, this one, inverse operations. I'm adding 9 first. I get 3x equals 9. Divide both sides by 3. X equals 3. So my two options are 10 and 3, which is letter C. If you get stuck right? You can always plug in these numbers and see if it works. But you'll see if you plug in 10 minus a negative 10, that's going to be 10 plus 10, which is 20. We're not going to get a 0 that way, right? So if you get stuck and you have multiple choice, you can always plug in numbers and see if they work or not. Number 10, this is important. Show your work. I really, really, really need you to get into the habit of doing this because they're about to get more complicated, and it's really important you show each step of your work. So I'm going to set each equation, x minus 6 equals 0, and x plus 5 equals 0. Using inverse operations, I'm going to add 6 to both sides. Negative 6 plus 6 is 0, so we get x equals 6 for the first one. I'm going to subtract 5 from both sides, and so x equals negative 5 for the second one. Let's try the next one. X minus 3 equals 0. I'm going to add 3 to both sides, so we get x equals 3. Our next one, 2/3 x minus 6 equals 0. Now, a lot of times when you all see the fractions, it trips you up. So remember, a fraction here is multiplication and division, right? So we're going to do inverse operations, and we're going to start with this negative 6. I'm going to add 6 to both sides. We get 6 on this side. Negative 6 and 6 is 0, so we're left with 2/3 x. Now, I want to get rid of the coefficient in front of x. Now, to do that, it's multiplication, so I want to divide. When I divide fractions, I keep change flip, or very simply, we can multiply by the reciprocal. When you multiply a fraction by its reciprocal, you will get 1. Because 3 times 2 is 6, 2 times 3 is 6, 6 divided by 6 is 1, or 3 divided by 3 is 1, 2 divided by 2 is 1. So you're left with x equals 6 times 3 is 18, divided by 2 equals 9. All right, if this is one that you are still struggling with, or I just did this and you said, what? Rewind it, watch it again, make sure you understand it, or come and ask questions at lunchtime. Negative 3x minus 15 equals 0. So again, I'm setting the first one, and then x plus 7 equals 0. Let's start with this one that's a little easier. I'm going to subtract 7 from both sides. We get x equals negative 7. It's our first one. Now for this one, again, this has a negative in front of it, but this is multiplication. So inverse operations, I'm starting with adding 15 to both sides. And then we get negative 3x. I'm going to divide both sides by negative 3. And we'll get x equals negative 5. All right. Consider these two expressions so that the two expressions define the same function. So to show that, I'm going to go ahead and multiply my factored form to show that it's the same as the standard form. So let's go ahead and do that. Now, you can use whatever method you are most comfortable with. I'm going to model here using the box method, and then you can also use FOIL. So 3x times x is 3x squared. 3x times negative 4 is negative 12x. Negative 6 times x is negative 6x. Negative 6 times negative 4 is positive 24. I can now combine my like terms. 3x squared minus 12x minus 6x is minus 18x plus 24. If I use FOIL, let me erase this so you can see a little bit better here. I'm going to start with my first. X times 3x is 3x squared. Outside, x times negative 6 is negative 6x. Inside, negative 4 times 3x is negative 12x. And then last, negative 4 times negative 6 is positive 24. I can then combine my like terms here in the middle, and we get 3x squared minus 18x plus 24. Again, same answer. Number 12. Kieran saw that if the equation x plus 2 times x minus 4 equals 0 is true, then by the zero product property, either x plus 2 or x minus 4 is 0. He reasoned that if x plus 2 times x minus 4 equals 72 is true, then x plus 2 is equal to 72, or x minus 4 is equal to 72. Why is Kieran's conclusion incorrect? So the reason this is incorrect is because the reason we can do this is the zero product property. With the zero product property, one factor needs to equal 0 to have a product or an answer of 0. 72 is not 0, right? So if I were to try and do this, right, let's say I said x minus 4 equals 72, that would mean x equals 76, right? If I plug that into this equation, 76, we'll get 76 on one side, and 76 plus 2, so 78 times 72. 78 times 72 does not equal 72. So this only works when we are multiplying to equal 0. All right, number 13. Andre wants to solve this equation. He uses a graphing calculator to graph 5x squared minus 4x minus 18 and y equals 20, and looks for the intercepts, or where the graphs cross, at the points. So it says substitute the value Andre found in the expression. So we're going to do that. So 5 times negative 2.39 squared minus 4 times negative 2.39 minus 18 equals blank. All right, you can solve that. You do the calculations for that. Then we're going to do 5 times 3.19 squared minus 4 times 3.19 minus 18 equals, and again, you're going to solve that. Find that there for me. Now it says, why did neither solution make 5x squared minus 4x minus 18 equal exactly 20? Now, you're going to tell me these answers, but know that they're not going to be exactly 20. And why do you think that is? Well, notice that we have decimals here. These decimals are estimations, or kind of approximations. They're as close to the real number as we could get, but there would be more place values to that decimal. Right? So it might be, for example, negative 2.39678, right? And we kind of rounded, or I guess that wouldn't be 2.39, but so negative 2.39412, right? And so we rounded it to negative 2.39, but that little bit of that decimal, that hundredths place and thousandths place, actually makes a very big difference. And so negative 2.39 and negative 2.39 and 3.19 are rounded to the closest hundredth, but they might actually be, that decimal be a bit longer, and so to get an exact calculation, we would need to use that whole decimal. All right, number 14, select all the solutions that are solutions to this equation. So inverse operations means, remember, PEMDAS, so we're starting with addition and subtraction. We don't have that here, so we don't need to do that one. Then multiplication and division. So we're going to divide both sides by 7, and we'll get x squared equals 34 divided by 7 is 4, times 7 is 28, 63 and 9, 49. Okay, so now we've done multiplication division. We're now at the exponent part. So I'm going to take the square root of both sides, and I will get x equals plus or minus 7. So we can write x equals as positive or negative 7. Either of those would work. We can also write it as the square root of 49. Okay? We cannot write it as f, because we cannot take the square root of a negative number. That does not give us a real number. That's a separate conversation. 49, if we put 49 times 49 in there, it's going to be much greater than 343. And then if I put in negative 7 times negative 7, that would just give me 7. And 7 times 7 is 49, so that does not work. This one is actually also an answer, because negative the square root of 49, right, times itself squared is going to give us a positive number, right? So it's going to give us a positive 7, because anything squared is going to be positive. So this one could potentially work for us. All right, let's go ahead and take a look at our next problem. All right, for this last problem, this is a park practice problem. Remember, we're now calling park Cape. All right, but it's your test. And so it says this is the original equation, f of x, and this new equation on the graph is g of x. What is the difference here? So our original equation would have been starting here, right, at the origin. It has flipped upside down, which means we have a negative coefficient. So I'm going to cross out a and b because the only place we have negative coefficients are for c or d. So that's first thing. The next thing is my vertex has moved over 2 to the left and has moved up 1. So I know at the end I need a plus 1. Both of these have plus 1. Now I need to decide, am I minusing, subtracting 2, or adding 2? This vertex here would be positive 2 comma 1, because remember this minus is part of the equation. And so this would have a vertex over here. However, this one is the same as x minus a negative 2, which means the x value here is negative 2. And so D is our best answer option. This is asking you to be able to tell, based on this equation, what coefficient should I have and what vertex should I have and how should that be written. Our next park problem, which it should be on the same page as yours, for some reason it got shifted down on mine, but it's asking what is the equivalent form of the function. So we're looking for what will give us the zeros of this function. Well, a and b are both what form? If you have parentheses with a square and then a number being added at the end as a constant, this is vertex form. Vertex form is not the same as our factored form and therefore does not give us the zeros, right? So it needs to be either C or D. So now what we want to do is let's go ahead and multiply these and figure these out. Now, I'm going to give you this hint in that we're looking at signs here. Notice all of these signs are negative. So let's take a look at this. We're going to leave this negative alone. Let's start with our parentheses. And so we'll get negative, put that there, and then we're going to rewrite this. X times x is x squared. X times 6 is plus 6x. 2 times x is plus 2x. 2 times 6 is 12. So this is now going to be 8x, not 18, excuse me, 8x. And so when I multiply by the negative now, I will have negative x squared minus 8x minus 12. That looks pretty good, right? I want all those negatives there. This is a minus 12. Now, I want to show you why this one is wrong. So make sure you look at all answer options. So x times x is x squared. Remember, we're going to put this negative out there. Leave that there so we don't forget about it. Negative 6x minus 2x plus 12. So what happens now when I multiply this negative through here, my middle term is going to become positive. So this would be negative times x squared minus 8x plus 12. When I multiply a negative through, I'll get negative x squared plus 8x minus 12. And so that's where this goes wrong, is because of this sign. That negative middle term or linear term will become positive when I multiply it by a negative, and we want it to have a negative here. So this is going to be answer C. Now on a test question like this, if it is in the calculator section, you could also plug both equations in the calculator and see if they look the same, right? That's another way to check it. However, most likely this type of question will be on the non-calculator section because they want to see that you understand how to convert this into standard form and make it look like this. Okay? All right, that is it for your homework. Your code word for today is shark. Shark is your code word for today. Put it at the top of your paper. Happy homeworking, and I will see you tomorrow.